Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss all four problems asked in today's LeetCode Weekly Contest 471. So let's start with the first problem. It says you are given an integer array nums and an integer k. Now you have to return the integer that denoting the sum of all elements in the nums whose frequency is divisible by k, right? Or 0 if there is no such element exist. So you have to find out all the numbers, the sum of all the numbers whose frequency is divisible by k, right? So an element is included in the sum exactly as many number of times as it appears in the array if its total frequency is divisible by k, right? So for example here, if you see the frequency of 3 is 4, right, which is even, so we have to add all these, like the sum of all these numbers, so 3 into 4, right? So your sum is going to be like added by 12, right? So it's not like you just have to like include 3 one number of times. No, you have to include 3 as many number of times as is present in the original array, right? So yeah, this is an easy problem. Let's see the code directly, right? So here is the code. This is my nums array and this is the integer k. Now what I have done, I have used a map so to store the frequency of each numbers, right? Now this is my answer. Now what I'm doing here, I'm going through each pair of value and frequency from this map, right? So I'm just checking if the frequency is divisible by k or not. If the frequency is divisible by k, then just your answer is going to be increment by value into frequency, right? So because this value comes these many number of times, so we have to add all the occurrences of that number, right, and add then return the answer, right? So yeah, this is all about the first problem. Now let's look at the second problem. In the second problem, you are given a string s that consists of lowercase English letters. Now a substring of s is called balanced if all distinct characters in the substring appear same number of times, right? So the frequency of all the distinct characters are same in that subarray, and we have to return the length of longest balanced substring of s, and we know what is substring. So for example, in this test case, your output is 4, because if you see here for this length 4 subarray a b b a, the frequency of b is also 2 and the frequency of a is also 2, right? So here the answer is 4. Yeah, so yeah, this is a good problem. Let's see how we can approach it. In this second problem, if you notice, your n is up to 1000, right? So we can easily apply order of n square solution, right? So let's see how we can do it. So this is your string, right? This is your, let's say, string 0 1 2 3, right? These are the indices. So what we will do, we will go through each possible uh, uh, pair of left index and right index. So let's say I choose this as a left index and this is the right index, right? And I want to check if the frequency of all the distinct characters in this subarray have the same frequency, right? That's essentially what we have to check. And if all the distinct character have the same frequency, then this is a balanced subarray, right? So then your answer is going to be a maximum of answer comma this length. So the length is r minus l plus 1, right? So now the job is just to check if the frequency of all distinct character is same or not, right? So if you notice, there are at max 26 characters, right, from a to z, right? So what we will do, we will kind of a help, so we will take a help of a prefix sum concept. So at each index we will store frequency of, so let's say there is a vector, 2D vector of prefix, or I would, let's call it, I would prefix I and 26, right? So essentially this prefix of I 0 will tell you the number of occurrence of character A from subarray 0 to I, right? So number of A in the subarray 0 to I, right? Similarly, prefix of I 1 would tell you number of character B in the subarray 0 to I, right? So once you store this frequency, so once you store this like the frequency of all the characters in this prefix sum, in this prefix array, we can easily find the characters of A, B, C and D, right? So from L to R, the frequency of A is going to be prefix of PRE of R 0 minus PRE of L minus 1 and 0, right? Similarly, frequency of B, that is going to be PRE of R1 minus PRE of L minus 1 and so on, right? Similarly, we will find the frequency of Z, and that is going to be PRE of R25 minus PRE of L minus 1 and 25, right? So once you find the frequency of A, B and C up to Z in this subarray, we can just quickly check for all the distinct characters. So distinct characters means the frequency is greater than 0, right? If the frequency is greater than 0, then all the frequency is same or not. If all the frequencies are same, then it means that this is a balanced subarray. So we can just update our answer, right? So yeah, this is all about the explanation part. So the complexity for this code is order of n into n to go through each possible possibilities of left index and right index, means all possible subarray, into 26. So 26 to find the frequency of all the 26 characters, right? So yeah, this would be accepted. So let's look at the code now. Here is the code. This is my input string and this is the length, right? So I created a this prefix array, right, to store the frequency of each 26 character at each index, right? So at index 0, we have just one character, so as of 0 minus A, right? So here your A would be designated as 0, B would be designated at 1 and so on, and Z would be designated as 25, right? So now from index 1 onwards, your prefix of I is equal to prefix of I minus n, then just update the frequency of that particular character that is present at the ith index, right? So once you build the prefix array, the job is easy. This is my answer. I'm going through each possible ways for left index and right index. I'm just checking if the frequency of all the characters is same or not, right? So this is the this is my OK. So OK will tell you if all the distinct characters have the same frequency, right? So here what I'm doing here, so I'm just trying to find the frequency of that particular character. So let's say I'm iterating from 0 to 26. So the frequency of this particular character is going to be prefix of RC minus prefix of L minus 1C as per the explanation, right? So you can check it out. So once you do that, just check if the frequency is non-zero, means this is a distinct character. So just check if it matches with the previous frequency. So this will tell you the frequency, the unique frequency, right? So if the frequency is -1, means that this is the first distinct character, so just update the frequency. Otherwise, if frequency is not equals to f, means that there are at least two distinct character, but the frequency are not same, then your OK is going to be 0, means this subarray from L to R is not a balanced subarray, and then break it, right? So just check if OK, then just update the answer. Answer is going to be maximum of answers comma R minus L plus 1, and at the end return the answer, right? So yeah, this is all about the second problem. Now let's look at the third problem. This is the third problem asked in today's contest. So this problem is almost same as the second problem, just few differences. So the difference is, so in the second problem we could have all the characters from A to Z, right? But here your characters could be either A, B or C, that's it, right? And we already know what is the balanced substring. So balanced substring is called if all the distinct character in the substring appear same number of times, right? And we have to return the length of longest balanced substring, right? So here if you notice, your constraint is a bit high. So earlier it was up to 10 to the power 3, but here it could be up to 10 to the power 5, right? So yeah, this is really a good problem. Let's see how we can approach it. In the third problem, we know that all the characters in the given string s is going to be either a, b or c, right? So to solve this problem, we will do something unconventional. So what I have done to solve this problem, that let's say I created a three function. One is calculate 1, second is calculate 2, third is calculate 3. So in calculate 1, what it will calculate, it will try to find the max length of a maximum maximum length of a balanced substring such that all the characters are same as that particular character. Let's say I pass x character, right? This x could be either a, b or c. So in calculate 1, it will try to find the maximum length of a balanced substring such that all the characters are same as x, right? This is the first case, calculate 1. Now in calculate 2, I will pass here two characters. Let's say I passed character AB, right? So what it will calculate, it will try to find the maximum length of a balanced substring such that all the characters in this substring is either A or B, and they both are same. Like the frequency of A and B are equal. Now in calculate 3, what I will do, I will try to find the maximum length of a balanced substring such that all these three characters A, B and C exist and they have the same frequency, right? Frequency of A is equals to frequency of B equals to frequency of C, and here frequency of A is equals to f of B, and there won't be any C. For example, here if A, so in calculate 2AB, in that balanced substring only A and B would be present and they would be having the same frequency, right? So this is all about this calculate function, calculate 1, 2 and 3. Now let's see how do we check all the characters have the same frequency, right? To find the calculate 2 of A and B, what we will do, we will make use of a prefix sum concept, same as the problem number 2. Please check out the problem number 2. So here there what I have done, I stored a frequency array, right? So the prefix, so prefix of I and 0 will tell you the number of A, number of A from index 0 to I, right? Same for other characters, right? So here let's say this is my left index and this is my R index, right? The frequency of A and B at this particular index is, let's say, AR and BR, right? So this AR essentially nothing but AR is prefix of R and 0. Similarly BR is prefix of R and 0, right? So let's say, and similarly here let's say this is my AL and BL, right? So this is left index, this is right index, this is L plus 1. Now let's say I claim that this subarray from index L plus 1 to R is a balanced substring, right? What it means? It means that the frequency of A and B is going to be same, right, in this subarray from L plus 1 to R. Now what is the frequency of A? Frequency of A is going to be AR minus A. So since we are focusing from L plus 1 to R, so this is one previous index, A of L, right? Similarly f of B is going to be B of R minus B of L, and to make the substring balance, your FA is going to be equals to FB. What it means? AR minus AL is equals to BR minus BL, right? If you refactor it, you would find that AR minus BR is equals to AL minus BL, right? That's the most important point. So see here, your AR minus BR is going to be AL minus BL. So the job is easy. Just check the leftmost index such that this AR minus BR is same as like, so we will store a map here, right? We will store a map of int comma int. So this would essentially store the mapping of this AI minus BI. So your MP of AI minus BI is going to be I, right? So we will try to find the leftmost index such that that is present in the map. If that is present, then just update your answer. right? So yeah, that was for calculate 2. Now for calculate 3, this is a bit just slightly advanced. Let me clear it first, right? So in calculate 3, what we have to do, so we know that this is my br, right? This is 1, and my similarly for cr, so here it would be having some cr value, right? So this is al, bl and cl. This is going to be pre of r and 2, right? So here same concept. Your fa is going to be for l plus 1 to r. Your fa is going to be ar minus al. Similarly, that is equals to br minus bl, and that is equals to cr minus cl, right? So here, just so if you do equality of these two, your this is going to be uh, ar minus br is equals to al minus bl, right? Similarly, here your ar minus cr is going to be al minus cl, right? Since both are equal, just make, so here, so in calculate 2 we had a map of int comma int, right? Int comma int. But here it would be having a map of pair of int comma pair of int comma int comma int, right, to store the index. So here we will store ai minus bi comma ai minus ci, right? And that is equals to I. So yeah, please watch the video once again if you have any difficulty like in anywhere, and like if you don't understand anything, please write a comment. I'll explain it, right? So now let's look at the code. So here is the code. This is the input string s, right? This is my length and this is my answer. So I created 3 functions as discussed in the explanation part: calculate 1, calculate 2, calculate 3, right? So now let's directly look over to the here. So here first find the answer for calculate 1. So calculate 1 will tell you the maximum length of a substring that contains a single character, right? It could be either a, b or c. Then for calculate 2, there are 3 possibilities: either it could be ab or ac or bc. And then at last find calculate 3. So calculate 3 will tell you the maximum length of a substring such that all 3 characters a, b and c are present, right? And at the end return an answer. So now let's look individually calculate 1. So here this is the calculate 1. So I'm going through each possible indexes from I is equal to 0 to 1. I'm just checking if the character is same as previous, count plus plus, otherwise count equals to 1, and then update your answer, right? Similarly for calculate 2, as discussed in the explanation part, for a and b we have to store the value of a minus b, right? So initially map of 0, mp of 0 equals to minus 1, right? And this is my x and y. So x will tell you the frequency of a, y will tell you the frequency of b, right? And then I'm going through each indices from I is equal to 0 to n, right? If this is a, x plus plus; if this is b, y plus plus. Otherwise, since we know that we only have to find the length of the maximum length of a substring that contains only a and b. If c is present, just remove it, right? And by the way, this a and b is not character a and b. This a and b could be either like any one of these 3 combinations, right? So just clear it if this is some different character. Otherwise, just check if the x minus y is present in the map or not. If it is present, update your answer, and if it is not present, just update the latest value, right? So this is for calculate 2, and this is for same for calculate 3. So in calculate 3 we have to store a mapping of x minus y and x minus z, right? Please check out the explanation part. So similarly for 0 0 minus 1, this is the frequency of a, b and c. So for a, frequency is x, for b, frequency is y, and for character c, frequency is g. Now I'm going through all the characters. If it is a, x plus plus; for b character, y plus plus; and otherwise c, z plus plus. I'm just checking if x minus I and x minus j pair is present in the map or not. If it is present, update your answer; otherwise update with the latest value, right? So yeah, this is all about the third problem. Now let's look at the fourth problem. In the fourth problem, you are given an integer n and an undirected tree that is rooted at node 0 with n number of nodes numbered from 0 to n minus 1, right? And this would be represented in a 2D array that would contain all the edges from index ui to vi, right? And these edges are undirected edges. So if you have an edge from ui to vi, then vi to ui is also possible, right? And you are also given an integer array nums where nums of I is a positive integer assigned to that node, right? Now define a value ti as the number of ancestor of a node I such that the product of nums of I into nums of its ancestor is a perfect square. All right. And we have to return the sum of all ti value of all the node phi in the range and 1 to n minus 1. Okay. Right. So yeah, this is a good problem. Let's see how we can approach it. In the fourth problem, we are given a tree, right? And that is rooted at index 0. And we have to find out the number of ancestor for any node such that the product of value of that node, let's say I'm focusing on this particular node, let's say that node is I, right? So value at I into value at of its ancestor is a perfect square. So if it's a perfect square, it means that there would exist some number k such that your a of I into a of ancestor is equal to k square, right? Something like that. So I hope everybody aware of what are the ancestor. So I'll just quickly explain. So for 4, 1 and 0 is the ancestor. For 6, 4, 1 and 0 is the ancestor. So these are the ancestor. For 6, 3 is not an ancestor. So just keep in mind that for 6, I mean all the nodes that appears in the path from that node to root node, these are the ancestor, right? For 5, 2 and 0 is the ancestor. So yeah, that was about the ancestor. Now we know that your a of I, the value at ith node and value at its ancestor is going to be a perfect square, right? What it means? It means that let's say your k is the prime factorization of k is something like p1 into e1, right, into p2 into e2, right, and so on, right? So we know that a of I into a of ancestor is going to be k square. What it means? So if you do k square, right, this is going to be p1 into 2e1. So e1 is the number of times p1 occurs, right? So into this is going to be p2 to the power 2 into e2, right? So I hope you understand this part. So what I'm doing essentially here, let's say you have a number called uh, 20, right? So 20, the prime factorization is 2 square into 5, right? So here p1 is, so I can represent is 2 to the power 1 into 5 to the power 1. So essentially this p1 is 2, p2 is 5 and e1 is 2 and e2 is 1, right? So yeah, so we know that in k square all these like the power of each prime factor is going to be even number of times, right? Even number of times. So I can make use of this information. What I will do here, I will first normalize these values. I will normalize these values. What it means, so we are given this nums array, right? Nums array for all the nodes present in the tree, right? I will normalize it. So let's say I plan to normalize this a of I. What I will do, I will first find the prime factors of a of I. Let's say uh, a of, so let's say the prime factor of a of I is something p1 to the power, let's say this power is even, right? Even. So let's say this is 2 into even, for example, into, let's say there is some other prime factor that is occurs odd number of times, right? So let's say this is 2e2 plus 1. What I will do, the norm and so on in the normalization part. So once I plan to normalize it, what I will do, I will just discard all these odd numbers, sorry, all these even power of prime factors. In the odd power of prime factors, I will just keep it one number of times. So essentially ai, the normalized value of ai is going to be p2, that's it. Like for example, like so multiplication of all odd frequency prime factors, that is the normalized value of ai. I'll tell you why. I'll tell you how it helps. So let's say let's take an example. Let's say your first number is something like 2 to the power 3 into 3, like, so this is 12. Like, let's say the first number is 12, and let's say the second number is 27, right? So this is 3 to the power 3, right? We know that 12 into 27 is going to be a perfect square, because if you multiply these two, your 12 into 27 is equal to 2 to the square into 3 to the power 4. See, so this is a perfect square of 2 into 3 square. So this is 18 square. So multiplication of 12 into 7 is 18 square. But if you look it closely, if you normalize this value, so the normalized value of 12 is going to be, we will discard all the even power prime factors, odd power prime factor, I will keep it one term. So 3. The normalized value of 12 is 3. Similarly, normalized value of 27 is also 3. See, these two are same. That's the beauty of this problem. The thing is, if you normalized all the values of the node, instead of finding the ancestors as that the multiplication is a perfect square, just check how many ancestors are there whose value is same, whose normalized value is same as my normalized value, right? So see here, 3 and 3. That is why if you so if they are same, so if you multiply them, they are still going to be a perfect square, right? So yeah, I hope this part, so please watch this video once again if you didn't understand this part. So now instead of finding all the ancestor such that a multiply perfect square, just find all the just find all the ancestor whose value is same as me after normalization, right? So yeah, now the problem is like becomes pretty straightforward. It's just an implementation of DFS. So yeah, I hope everybody has solved at least one problem in tree, like how to do a basic DFS in tree, right? So what we can do here, we will store a map, right? We will store a map to store the count of each normalized value, right? So once I start DFS from this root node, I will start exploring this child node, right? So I will so I will update this map. So this map essentially like for each of the normalized values, it will increment its frequency. Now let's say I reached at this particular node I will just check how many ancestor are there whose normalized value is same as me. So that would be stored in this map. So your answer is going to be plus equals to, your answer is going to be plus equals to mp of that value, a of I. So a dash I would call it. So a dash is the normalized value of I, right? That's it. And apart from this, you use a basic DFS. Now the last job, how do I find the normalized value, right? How do I find the normalized value of A of I? That's the last thing to discuss. So I hope everybody is aware of sieve algorithm, right? So sieve algorithm used to find all the prime numbers in the range. So here the numbers could be up to 10 to the power 5, right? So we can use sieve's algorithm, help of sieve algorithm. So it will, so using sieve algorithm, it will give you all the prime numbers, in the range up to 10 to the power 5. Also it will give you SPF. SPF is the smallest prime factor, right? So just find this SPF, smallest prime factor, and all the prime numbers, and then like so if you know the smallest prime factor and the prime number, you can easily find the normalized value of A of I. How? Let's say my current number is Z, right? I want to find the normalized value of Z. I will first find the SPF of Z. Let's say that is SP, right? So I will keep on dividing this as Z. So if SP is the smallest prime factor of G, it means that your Z would be some SP to the power some K, right? So what I will do, I will keep on dividing this Z by SP, and I will store the count somewhere, right? Then at the end, I'll just check if this count is even or not. If this count is even, I just discard it, because like if you have gone through my explanation, you understand that if the count is even, just discard it. And otherwise, if the count is not equals to 0, your normalized value is going to be multiplication equals to that SP, smallest prime factor, right? So yeah, that's all about the explanation part. So now let's look at the code. So here is the code, right? So in this function we are given an, ages, and the nums value, right? So first, uh, what I have done here, I have make use of Sieb's algorithm to find all the SPF values, SPF and the is prime, right? So this will tell you the prime numbers in the range up to 10 to the power 5, and similarly SPF, right? Then for all these edges, I have created an adjacency list. So in adjacency list, u dot pushback b and v dot pushback u, the standard. Then there are a couple of maps. So these maps, I have cleared it first. Answer is going to be 0. Now what I have done here, I have updated all the values in the nums to its normalized value. So here see, x is going to be normalized value of x, right? So please check out the explanation part. I have explained there. So this will store the normalized value. Then I have used a DFS, standard DFS. This is my node, this is my parent node, and this is my nums value. So nums will tell you the normalized value now, right? Now this is the normalization code. Please write it by yourself. You would understand it better. So I've done the standard things. I've not done anything magic. So if your x is not, so till while x is not equals to 1, find the smallest prime factor, keep on dividing it, right? Just increment the count. Just check if the count is odd, then your result is going to be multiply by this SP value, and at the end return this result, right? So this is the normalization code, like the normalization function. And then this is the basic simple DFS, right? In DFS, for what I'm doing here, your answer plus equals to all the ancestor that have the same value as me, so that would be stored in the map, right? Then I incremented the map of this current normalized value. Then I'm going through all the neighbors of it, right? All the childs of it, and at the end just subtract it, right? So yeah, I hope you understand this problem, right? So yeah, if you find the video helpful, please like, share and subscribe to my channel. Thanks for watching. Have a nice day.